And welcome back. Now, this is my second video on moles in just a couple of days. If you want to see the first video on moles, which is basically a beginner's guide that allows you to calculate how many moles there are in a certain mass, or even just to explain what a mole is, then click on that link in the description. This video is going to concentrate on the harder GCSE moles questions that you're likely to get, sort of those grade 7 and above moles questions. If you're watching this on my channel, the Cat Science and Maths channel, also check out the link in the description to the Core Learning Network YouTube channel. There you'll find myself and a bunch of other creators providing regular educational content for you while the schools are shut, so you don't feel as if you're falling behind.
Yeah, check it out. The other creators are way better than this bald guy here with the big nose, and they cover loads of subjects too, so go and click that link in the description.
So before I introduce the question we're going to be answering, it's really important we have a review on why we balance equations, or what a balanced equation tells us. If we have a look at this equation here, I have balanced it for you. I have put a 2 in front of the Na, or sodium, a 2 in front of the H2O, which is water, and a 2 in front of the NaOH, which is a sodium hydroxide. When an equation is balanced like this, it tells me how many moles of one element or compound I need to react with however many number of moles of a different compound. So if I've not explained that well, what I mean is, in this example, if I want to react sodium and water together without wasting some sodium or wasting some water, then 2 moles of sodium will perfectly react with 2 moles of water to make 2 moles of sodium hydroxide and 1 mole of hydrogen. So these numbers in front tell us the ratio of moles, or the ratio of number of molecules. And I can go a step further. I could say a chemical reaction that produces 2 moles of sodium hydroxide will produce just 1 mole of hydrogen. Or a chemical reaction that produces just 1 mole of hydrogen is going to require 2 moles of sodium. If we look at it in that way, then what I'm about to introduce to you is going to become a lot more easy.
Okay, we're a couple of minutes into the video and you've not even introduced a question yet. Will you get on with it, you absolute potato? And another thing, nobody says a lot more easy. It's easier, that's the word. You're supposed to be a teacher, for God's sake, man.
Well, here is the question. The question is going to tell me that I have 72 grams of sodium. Now, at this point, I'll tell you the mass number of sodium is 23. Maybe jot that down or bear that in mind. So I've got 92 grams of sodium.
Show off.
So how much sodium hydroxide can I make? What mass of sodium hydroxide can I make? Now, if I get a question like that, they can seem at first quite confusing. So what steps can we follow to make it as less confusing as possible? Well, the steps we can take are, we can look at the 2 compounds, or the 2 elements, or the element and the compound that are mentioned in the question, and we can cross out everything else. Alright, my question here only tells me that I have 92 grams of sodium, and it wants to know how much sodium hydroxide I'm going to make. Everything else can be crossed out.
Yeah, only the chemicals in the question need to remain. You can cross everything else out. It's not a problem. You could cross it out with a pen. You could cross it out with a ruler. You could cross it out with a bazooka. Yeah, do that.
Now, from that point, I'm going to look only at the 2 numbers in front of these compounds or elements. And here I have a 2 and a 2. And I'm going to see if I can find the simplest ratio of them. We'll see why in a second. But if I have a 2 and a 2, right, a ratio of 2 to 2 boils down to essentially 1 to 1. What this tells me is, if I had 1 mole of sodium, I would make 1 mole of sodium hydroxide. Because if I have 2 moles of sodium, I'm going to make 2 moles of sodium hydroxide. So I'm going to boil that down to the simplest ratio. It's a 1 to 1 ratio.
Wow, that is fascinating. Your amazing personality does not make this boring at all. Why do you want to work out a ratio anyway?
Yeah, so why have I done that? Well, we know that if we've got 92 grams of sodium and we know the mass number of sodium is 23, we can figure out exactly how many moles of sodium we've got. And if we know how many moles of sodium we've got, and we know, for example, that 1 mole of sodium gives me 1 mole of sodium hydroxide, that can tell me how many moles of sodium hydroxide I'm going to make. So if I end up with 10 moles of sodium, I'm going to have 10 moles of sodium hydroxide. If I have 20 moles of sodium, I'll have 20 moles of sodium hydroxide. And that's going to allow me to work out the mass of sodium hydroxide that I've got. So, I guess the question is,
oh, I know. How many moles of sodium do we have?
How many moles of sodium do I actually have?
Told you, yeah, I'm smashing it, like your mummy's favourite plant pot.
Well, I said to you before that the mass number of sodium was 92. Sorry, the mass number of sodium was 23.
God, this guy's a moron.
But the question tells us that we have 92 grams of sodium. So 92 grams with a mass number of 23. Now, at this point, what I see a lot of my pupils doing is getting confused because the big 2 is still at the front of each of these compounds. And people start thinking they have to do something with that. People start thinking that they have to maybe double the mass number of sodium or double the molecular mass of sodium hydroxide. And it gets a little bit confusing. So what I'm going to say is, at this point, once you know the ratio, rub those numbers out. They're not important. They are only important for figuring out the ratio. So if this was me, this is what my question would have looked like now. I'd have scribbled out everything else. So now I can answer that question, how many moles of sodium do I have? Well, 92 divided by 23 gives me 4 moles of sodium. And because I know the ratio, because it was a 1-to-1 ratio, I'm going to have 4 moles of sodium hydroxide. So what mass is that going to be? Well, sodium has a mass number of 23. Oxygen is 16. You should know the mass number of oxygen. And hydrogen is 1. So if I want to figure out the mass of sodium hydroxide I'm going to add those together to get the mass of 1 mole of sodium hydroxide. So 23 plus 16 plus 1. And I'm going to times that by 4. And that gives me 160 grams. Now what I want you to do before I set you a question yourself is just to go back and have another listen to that explanation. Maybe pause the video now. And then we'll go through one a little bit quicker but using the same method.
Okay, a serious note now, a serious one, honestly. No, I was only kidding. Right, a serious one. When you look at this question coming up, pause the video and see if you can follow those steps and work it out for yourself. Right? If not, he'll guide you through the steps, but then pause it as regular as you can to see if you can predict what's coming next. Once you know all the steps, you'll be able to answer any of these questions. Yay!
Right, so question 2, and we're going to use the same equation, but this time the question has changed. This time I've been given 92 grams of sodium, but how much hydrogen am I going to make?
Remember, pause the video now. Try and work it out. Don't let him do all the work for you.
Now, do you remember the steps from that first example? The very, very first thing we did was rub out anything that wasn't mentioned in the question. So they all disappear. Only sodium and hydrogen were mentioned in the question. That was the first step.
Okay, hope you got that. Now remember, that was the first step. What was the second step? Try and come up with it yourself.
Now the second step was looking at the ratio of moles or molecules in the equation, and we can see that 2 moles of sodium will produce 1 mole of hydrogen. It's a ratio of 2-to-1. So however many moles of sodium I've got, I'm only going to have half that for hydrogen. So for every 2 moles of sodium I've got, I'm going to make 1 mole of hydrogen. Now we've already seen that we have 4 moles of sodium. 92 divided by 23 gives me 4 moles, which means we're only going to have 2 moles of hydrogen. It's a 2-to-1 ratio. So hydrogen has a mass number of 1, but this is H2, it's a molecule. So the mass of 1 mole of hydrogen gas is going to be 1 plus 1, that gives us 2. Times 2, which is the number of moles we've got, is going to give us 4 grams. And I really should have put grams as units on that PowerPoint. Naughty me.
No, you mean naughty me. I've just weed on your dinner.
So question 3, and this time we're going to use a different equation. This time we're going to use the reaction of sodium with chlorine to make sodium chloride. And we are told that I need 2 moles of sodium to react with 1 mole of chlorine gas, and that will produce 2 moles of sodium chloride. That's the ratio. It's a 2-to-1-to-2 ratio. Now, if I have 142 grams of chlorine, what mass of sodium chloride will I make? Can you remember what the first step is?
In fact, can you answer the question this time without any help whatsoever? So just wind back 10 seconds, write it down, and then have a go with the video paused. And while you're doing that, I'll tell you a story. It goes a little bit like this. There was a guy called Fred who walked up a hill and his leg fell off, and then his other leg fell off, and he got stuck on top of the hill. It's a good story, yeah.
Hopefully you could. Hopefully you remembered the first step is just to scribble off anything that isn't mentioned in the question. The only things mentioned in the question here are chlorine and sodium chloride. So everything else disappears. What was the second step?
Ratio, 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 ratio.
That's right, the second step was to get the ratio. We know it's a 1 to 2 ratio, so however many moles of chlorine we have, we are going to make twice as many moles of sodium chloride. If I add 2 moles of chlorine, I'm going to make 4 moles of sodium chloride. If I add 10 moles of chlorine, I'm going to make 20 moles of sodium chloride.
Yeah, and if you had 100 moles of it, you'd still be bald, so shut up and get on with it.
So what is the next step? Well, the next step is remembering that 2 now in front of the sodium chloride isn't needed. We don't want it to hang around there and confuse the next step, so we're going to scribble it out. We're just going to get rid of it. Remember, those numbers are only there to allow us to figure out the ratio of moles. So how many moles of chlorine do I have if I have 142 grams? Well, chlorine gas is Cl2. We can see at the bottom of the screen that chlorine has a mass number of 35.5. So 35.5 plus 35.5, because it's Cl2, gives us 71 grams per mole. But I have 142 grams. So 142 grams, right, in my hand, divided by 71, which is the molecular mass, gives us 2 moles. So if I've got 2 moles of chlorine gas, how many moles of sodium chloride am I going to have? Well, I'm going to have 4 because it's a 1 to 2 ratio. So how am I going to find out the mass of sodium chloride? Well, I'm going to add together the sodium and the chlorine, 23 plus 35.5, and I'm going to times it by 4 because I've got 4 moles. And that gives me 234 grams. So if I started off with 142 grams of chlorine, I could make 234 grams. Now in the next video, we'll look at why we might not get that. We'll look at theoretical yield and percentage yield, etc. But for now, these are going to require some working through. My advice to you is just to follow each example I've done and write down the steps that I've taken and then apply that to your own exam questions. Good luck with it. It's not easy.